Welcome to Lesson 2, Right Triangles. Here we'll be using trigonometry to find side lengths in various word problems. So example 1. A ladder rests against a house at an angle of 14 degrees. The top of the ladder touches the house at a height of 10 feet. How long is the ladder to the nearest tenth? On any word problem, you should start off by labeling your diagram, if you have one. Otherwise, you will have to draw your own. Then once your diagram is all labeled, you determine which trig ratio to use. So then determine if sine, cos, or tan should be used. And when you know which one you're going to use, you can just plug in your values into your ratio. So set up your ratios, the next step. You can use your SOHCAHTOA to help you do that. And once your ratio is set up, you're going to have to cross multiply to find x. So cross multiply to solve for x. The last point is a reminder. Make sure your calculator is in degrees. Okay, so let's start by labeling the diagram. It says the ladder rests against the house at an angle of 14 degrees. So they're referring to this angle here. Then the top of the ladder touches the house at a height of 10 feet. So that's this right here. And we're looking for the length of the ladder, so we'll call that x. So now in order to determine which trig ratio to use, we need to label our sides. X is the hypotenuse, and 10 is the adjacent. And looking at our SOHCAHTOA, I see that cos is the one that has adjacent and hypotenuse in it. So let's set it up now. Cos of the angle, cos of 14, equals 10 over x. Now the fourth step says we need to cross multiply now. So I can put this over 1. I'm going to multiply x by cos 14. And then set that equal to 1 times 10, which is just 10. Now in order to solve for x, we need to divide both sides by cos 14. They cancel. You get x equals 10 divided by cos 14. That works out to be 10.3 when you round to the nearest tenth. So now we can say that the ladder is 10.3 feet long. Now for example 2. Jane flies a kite at the park. The angle formed between a horizontal line and the string of the kite is 72 degrees. If the kite is 15 meters long, how high above Jane's hand is the kite to the nearest tenth? So let's start by drawing this horizontal line. It says the angle between the horizontal line and the string of the kite is 72 degrees. So that's right here. The kite is 15 meters long, so that's here. I'm looking for how high the kite is above our hand. So we can create our little right triangle here now and call this x. So now labeling the sides, I see that x is the opposite and 15 is the hypotenuse. So opposite and hypotenuse means we use sine. Let's set up the ratio. Sine of 72 equals x over 15. Now this time when we cross multiply, we're multiplying x by 1, which is just x. And we're multiplying 15 by sine 72. So there's no dividing in this one. We're just going to multiply these two together. Doing that gives me 14.3. So I can say that the kite is 14.3 meters above Jane's hand. Now for the last example, it says a train track increases in altitude by 5 meters. The angle at which the track increases is 1.4 degrees. What is the horizontal distance the track takes up to the nearest tenth? Well, this horizontal distance here is what we can call x. It says it increases in altitude, which means it increases in height by 5 meters. So that goes here. And the angle at which it increases, this little tiny angle here, is 1.4 degrees. It's not going to increase by much because it is a train track. So now, across from the 1.4 degrees is my 5, so that means this is my opposite, and x is my adjacent. So opposite and adjacent means I'm going to use tan for this one. Tan of 1.4 degrees equals 5 over x. Cross multiplying, I get x times tan of 1.4 equals 5. Now I'm going to have to divide by tan of 1.4 in order to isolate x. And then dividing 5 by tan 1.4 in the calculator, I get 204.6. So we can answer the question by saying that the horizontal distance is 204.6 meters.